says the transformation represented by M is equivalent to a transformation P followed by a transformation Q. So P then Q. So what's happened? Well, it looks to me like it's been... You can see C has ended up over here, so it's a rotation rather than a reflection. If C had been down here, it would have been a reflection. It's not, it's a reflection. So if we rotated the unit square down here first, so a rotation, so I reckon P is a rotation 90 degrees clockwise, about the origin, and when that happens, so if we draw a little sketch, C's here and A's here. To get the matrix that does that, we need to look at what will happen. So A will end up here. Sorry, that dash shouldn't be there. A dash will end up here, and C will end up here as C dash. So A dash's coordinate is 0, -1, and C's coordinate is 1, 0. So that's the matrix that represents a 90 degrees and a 90 degrees clockwise rotation. Shh! Give up! No! And then once we've got it down here, it then gets stretched. We can see that it ends up here instead. So the next one, Q's transformation, was a stretch. Scale factor 2, that's really important to say, in the x direction, or parallel to the x-axis. So to get that matrix, we just need to work out how that changes from the original unit square, A and C. So C won't move, C will stay the same, so that will be 0, 1, and A will go to, instead of being 1, 0, will be 2, 0. So a stretch scale factor 2 matrix transformation is 2, 0, 0, 1. It says give descriptions of the possible pair of transformations. So that's what I've got here: rotation 90 degrees clockwise about 0, 0, and stretch scale factor 2 in the x direction, and state the matrices which represent them. So I've got all of that. We can do a check to make sure we've done it right, we've not made a mistake. Okay, and I would always recommend you doing this because it doesn't take very long to make sure you've got your 4 marks. When we multiply our matrices together, do we get M? And in order to check that, we need to make sure we multiply them in the correct way. If we have a matrix P followed by a matrix Q to get M, that will be done by multiplying Q first, then P. Okay, remember it goes backwards. We talked about this in class. So do we get that when we multiply? Do we get M's matrix? So 2 times 0 is 0. 0 times -1 is 0. 2 times 1 is 1. Sorry, 2 times 1 is 2. Plus 0 times 0 is nothing, so it's just 0, 2. Bottom left is going to be 0 times 0 plus 1 times -1, so that's -1. And bottom right is 0 times 1 plus 1 times 0. So we've got 0, 2, minus 1, 0. 0, 2, minus 1, 0 is exactly what we had. So we have done it right. So this little check tells me I've definitely got my marks for this question.